Next, we're going to hear from Dan Shannon. He is the Executive Director of Go 360 for AGSI. Dan earned an MBA from Athabasca University and a postgraduate certificate in knowledge management from Royal Roads University. He graduated from the College of New Caledonia's Drafting Technology program in Prince George. Over the past several years, Dan has spoken and taught on geospatial issues across North America, Europe, Asia, and the Middle East, particularly regarding GIS project management and return on investment. Dan is a past president of the Geospatial Information Technology Association, and he's going to do a talk for us on enterprise GIS and big data, as soon as I find it here.
Good morning, everyone. Great to be here. I really think it's been a terrific day and a half, fantastic conference. Certainly some very interesting talks about some of the things that can be done with geospatial technology today. And it's I've learned a lot and been very encouraged by what I've seen here. And certainly a big thanks to the committee here for putting this together, and nice to see the support that the conference has from the community of professionals here. That's really good. So my background has been chiefly with working with a telecom company in Canada for a number of years before joining AGSI and working with GIS there. And I want to talk a little bit today about some of the challenges that we're going to have going forward, and perhaps more from the perspective of the utility and where I see most utilities at and where their GIS is and where it may need to be going forward. And with respect to big data, and I guess that's maybe not the whole picture, but it's a good part of what's facing us and our need to adapt. This is a picture I took a few years ago when I was vacationing in Germany, and I just thought it was terrific to see a tree that large and that old that's just grown on a wall somewhere. And it makes me think of the built landscape that you have. If it's been there long enough, just becomes part of the landscape. So as we put in our place our systems and our processes and our technologies and our ways of doing things, over time they will just become part of the unquestioned landscape, and they will become less distinguishable from the things around us that we can't change. Sometimes forget that we can't change them. So, and that's where I think is pretty indicative of where a lot of our utility GIS programs are. I want to talk a little bit about how do we get to where we are, where we're going with our GIS from the utility perspective, and what do we need to do to get there. Most GISs have been built, in my experience with my colleagues in different companies and utilities. It's certainly true in telecom, but it's also true in utilities and a lot of times in government and municipalities as well. But the GISs do exactly what they've been designed to do. But what they've been designed to do, for the most part, is support engineering operations. And most GISs, even back in '87 when we implemented our first GIS, there was a lot of talk about what the GIS could do for the corporation, all the things it would do to support different parts of the operation. This wasn't just for engineering. But at the end of the day, it was funded by engineering, it was implemented for engineering, and used by engineering. It was engineering that either edited or departments that supported them that did the editing within the GIS system. The data that was put in was collected with a view to support those operations. And so now as we've got into second and third generation systems, as awareness of GIS has become more broadly distributed throughout the organization, the GISs are still reflecting what they were created to do. And they continue to serve those engineering departments quite well, but they often have very large deficits in terms of what they can do to support the rest of the organization. Part of the reason is simply, if you are in finance and there's a lot of information you want to know about your assets within the GIS system, you're only going to be there if engineering found some value to put that same information in there for you. But if you had requirements out of that data that were different, and things that weren't supporting engineering, engineering is very likely not going to have extended their data model. They certainly weren't going to spend the time collecting the information, and they would have been very reluctant to take on extra data editing capabilities if it didn't support their operations. And it's hard to think that we would be that self-focused and we would think in silos, but it tends to be how operations work, and it's certainly been my experience in terms of talking with other folks and how their GISs have evolved as well. But in the end, it certainly has stunted our ability to go forward with our GISs and really make them work for the rest of the organizations. And when we start talking about where we need to be, we've seen a lot of presentations this last couple of days here. They're very exciting and very interesting things that can be done, integrating data with real-time data feeds, doing a lot of spatial analysis. But a lot of the analysis is one-time, even though it's repeatable, it's still essentially a manual process, working through, bringing data sets together, compiling them, doing a lot of extract, transform, and load operations on them, doing an analysis. You might get fresh sets of data, you might change your scenario, but you're almost consistently, even if it's scripted and well rehearsed, you're going through a manual process and you're working with data that is a cut or an extract and it's pulled, and you work within basically a laboratory environment on that data. And compare that to an operations environment. And some of the things that we're doing with our GIS, especially in the utility format, update cycles tend to be measured in weeks rather than being real time. So certainly a good example would be by the time a job is designed in a GIS system for a utility or a municipality, that job goes out into the field and construction builds it. It's reported back as built, probably goes through some sort of control center process, comes back to engineering. Quite often it's a physical package of marked up paper, sometimes it's electronic files, but the time it takes to have an as-built updated in the GIS system can take months, is not uncommon. And it tends to be that way across the globe. Jeff Seiss, who blogs on these things and talks about utility GIS and travels the world, and he says from his perspective, that's the #1 gap in records management, is that gap between the as-built through back to the office and getting that information back. So we don't have real-time systems, and we certainly aren't treating them like real-time systems. They certainly weren't built like real-time systems, and the workflows that support them are nothing like real-time systems. So, they create an opportunity for delay. There's an opportunity for error because you're moving work around. It could either be misplaced. People will just not bother because it's a lot of extra work. They don't usually see value in it for themselves, be involved in that movement of information. And it certainly doesn't maximize the parties at either end of the equation. You've got somebody putting in data later on in the process. They're probably more concerned with what's happening next rather than documenting what just has happened. Then you've got people at the far end of the line that probably don't really see a lot of immediacy. If they've taken the time to mark something up and they send it in, they can get their next job a few months later. They pretty don't even see the information they sent in 2 months ago. There's not a lot of positive reinforcement for them to provide that information. So it's really not maximizing the expertise or the experience of each of those parties. And let's talk a little bit about where we're going with that and why that's not okay, why that's not going to be able to continue if we really want to move forward with our GIS. And we see in the business world and in a lot of areas outside of folks who embrace GIS technology who weren't the first adopters. You just look at utilities, big government, because of the expense of implementing these systems, we're often the first adopters of these systems. And a lot of times we've left ourselves behind because we've put in place these systems that are essentially design tools, and they really haven't evolved in terms of their character. The data sets that have been built remain what they are, the uses remain very similar to what they are. But the geographic landscape, the spatial landscape has changed. The technology has evolved, the capabilities have evolved. Certainly the skills of the people that we have working with us have evolved, and the culture out there is changing as well. I guess one simple example would be when we first started putting in GIS, there was no way we would be putting editing capabilities out in the field for a large number of reasons. Well, one of the reasons, we just didn't have the technology. We certainly couldn't provide people connectivity back to the database. That certainly wasn't something that could happen in the, you know, in the 80s, the 90s, in the early 90s even. The other thing was the kind of devices we would give people were just awkward and cumbersome. The resolution of devices, they would have to be so large and heavy that they would just be unable to be used. Then on top of that, the software applications were very, very complex. We certainly weren't going to give somebody a very complex GIS design tool for them to do editing in the field. This wouldn't have happened. And certainly the skills of the people in the field, a lot of these people hadn't been using computers at all at that time. So the thought of having these folks doing this kind of work was probably just not even consideration from that perspective. But of course that's changed. The technology's improved, the resolution of devices, the mobility of devices, our connectivity back to through the networks has evolved. And then on top of that, the skills of people have evolved. People work with computers and mapping every day. So the language has changed. And certainly software has evolved. And some of the capabilities of putting applications in front of people that have very simple, very targeted, very specific graphic user interfaces has evolved greatly. And so now we have a lot of different things have changed to make some of that available. But also the culture has changed. We work in a culture now of social media. People are involved in telling the story. I guess open street data is a great example of how people who have a vested interest in the things around them contribute data. The data quality has been proven over and over again by various case studies to be equal or better than the commercial data of similar nature in those areas because the people around care about what they're doing. But we haven't really necessarily taken that and used that to our advantage in the utility. I mean, the same argument can be made that people who build the network, whether it's a gas network or whether it's an electrical or telecom network, are the ones that care about that information. They're the ones that know that the map they've been given or the work print they've been given from the office is inaccurate, that things aren't in the right place, that stuff is missing. Old things have been removed, they're still showing up on the map. They would love to make those adjustments. And if they're given the tools, they will do it. And you can trust them to do it. We've built a lot of security around our data editing practice to protect the data, but in a lot of cases we've protected the data from being improved by people who care about the data. So just a little bit about where we're going with big data when I'm talking about that. I'm just thinking a couple of different kinds of big data, and I'm certainly not an expert on all the different types, but for example, just in a couple of general categories, they're both characterized by density. Certainly some of the data, like LiDAR data, is geographically dense. There's a lot of information in a very small space. It was interesting talking to a fellow about surveying yesterday, and the traditional surveying, you would pick up maybe several hundred points would be a large survey across the site. And you would extrapolate your contour lines, and you would do your leveling and your sections all based on a really very limited number of points. Now you're getting millions of points overlaid. And on top of that, you're getting data over and over again in time series. So the amount of data that we're getting is much more geographically dense. And our GIS systems that we use for managing our assets aren't necessarily geared to or designed to handle that. And then they're temporally, they're dense temporally because we're getting readings from these smart grid meters, automated metering systems, weather sensors, all sorts of SCADA devices are coming in within microseconds of each other. And so the amount of data that's streaming to us over time is also very dense. So in some of these networks, you don't necessarily have a lot of more points. They often represent parts of your network you already have and have mapped, but you're getting much more information about them. The last thing that happened wasn't a change to it 10 years ago when a work order was last executed on that, or something was maintained or adjusted on that device. The last thing that happened to it was a few seconds ago when the temperature of your transformer changed. So when you're looking at updating your system and using it as an operational device, it's much different than having it as an asset record that you adjust over time. It's just a picture I took out of a hotel window in Hong Kong last year, and it just struck me as just how much is in there. One of our GIK board members, Steve Swayze, is also a pilot, and this trip to Hong Kong, he mentioned that he had heard that if you took the world's population, it was at the density of Hong Kong. The entire world's population would fit within the boundaries of the municipality of Houston, Texas. Now this says probably something about the bloated municipal boundary of Houston, but it also says something about the density of living in a place like Hong Kong. At the conference I was at, there was a fellow there who was in charge. What he did was train people to be utility experts. Not only they weren't designers, they weren't engineers. What they did was they managed working in the field, identifying work that was being done to utilities. In some places, within working right away along one side of the street, there were up to 33 different companies had assets within that profile. I'm sure, Mark, you had similar experiences in Tokyo. That kind of urban density is staggering even for ourselves. We don't have that same density everywhere we work, but it's just a sign of the amount of information that's coming to us, the amount of density of data that we're going to have to be dealing with. And the data is also characterized by speed. Certainly, the sensor data waits for no one. There's been a number of stories from my colleagues who have been doing work to support companies who have installed smart meters, and they've gone into their offices and just seen boxes and boxes and boxes of paper, and they won't ask what those were. So, well, what they've done is they've taken the readings from the smart meters, printed them out, put them in boxes, and put them on the side of the wall. This benefits no one, costs people a lot of money, and they've been sold something and they're getting no value out of it. This data just piles up and piles up, sort of like your magazine subscriptions. They just keep coming, and you can't read them fast enough, so you've got a pile of magazines that just annoy you. So we don't want that with our smart data, I suppose. Another kind of fast data is the data is only relevant for a length of time, and certainly we learn this when our principles of reinforcing behavior is that if you want to reinforce the behavior, there has to be some immediacy to it. And so people will update something if they can see that update very quickly. We saw a couple of examples of people doing some web-based systems where somebody can do something in the field, they're doing perhaps an audit, and you turn around and somebody in the office can see that happen right away. Worked for TELUS Geomatics, we did vehicle tracking, managers can see the fleets in real time. If somebody went over a certain speed, they get an email instantly, they're getting feedback right away. And people don't have time to wait for traditional workflow. Certainly when I started with the company, I was in forecasting for a while with the phone company, and I was doing 20-year forecasts, looking at the population growth and the development within an area and trying to forecast what we would be doing, so we would build and put cables in that would last for the next 20 years of demand. And we certainly don't do that anymore. We do just-in-time engineering. It's not always just-in-time, but we think it is. But we certainly are working on much shorter time frames. It's a competitive environment right now. We have to respond, not just based on our engineering needs, but because we have a lot of competitors in that communications field. And so our need to respond more quickly to information means that if you can get that data updated in the field, from the field, that's much better than having to come back into the office for someone to do. And most of our utility GIS design systems just aren't designed to handle that. So I'll just give a few examples here of some of the things that are being done. And in this case, I'm just using a few examples from some of our clients. But it's just the kind of thing we're seeing that people are demanding and needing to integrate their system and make them real-time and operational GIS systems. I'm using an electrical example, and I realize that most people are here are oil and gas, but similar types of monitoring activities are involved. But here, taking GIS data coming in from the sensors, but it's providing real-time reporting, making minute-by-minute decisions on where to dispatch people and what to do with your operations, and getting data that has to be acted on right away. And here's an example with one of our clients where we pull all the data together, and they can see what the outages all are, what their priorities are. It predicts the location of the outage based on who's out of service, and it allows them to manage the outage management activities and respond to critical requirements minute by minute. And not only they don't get an idea of what their network is like, they get an idea of what their network is like right this minute, right this second. And they can then make changes through the GIS. They can go back out and they can make changes, throw switches, make updates within their system, within their GIS system. So again, not something you're going to be doing in a system where you've got a proprietary GIS database and your ability to bring in and combine data as an extract, transform, and load process where you're going through and doing analysis. provide information out to your customers, as well as you can provide it out to the people in the field. They can interact. The example, for some of our customers, we provide geospatial-enabled social media engagement. So when people are not only phoning in an outage, they're more likely to be tweeting or providing an Instagram message to their friends that, hey, there's an outage, or this transformer across the street's on fire. We get our clients information about an outage quicker than they can through their own smart meter devices, quicker than they can through people calling in to report an outage, and they can more quickly define the extent of the outage, and they combine that right within their GIS on a real-time basis. And of course, you want people to be able to work on any device. Nobody wants to have to deploy a whole new set of hardware and get that out to the field. So you can do, people are looking to do asset analytics, and they don't want to do asset analytics on a what happened last year basis. When it comes to things like managing a real-time network, whether it's the flow of electricity or gas or water, you want to be able to respond right away, see where things are overloading, and make adjustments in your network. You can find out how those overloads are affecting the life of an asset. You can incorporate your media feeds to help give you an idea of what companies will find, before they've had a chance to get out in the field. They know what they're going to see based on some of these social media feeds that they can provide. So these are the kind of things you're just not going to get in a traditional utility GIS. So how are you going to get there? Are you going to change out your existing GIS? Well, perhaps someday you will. For the most part, you're not going to just completely scrap it. But one way to do a bit of assessment is perhaps there's an appetite to develop a maturity model for your GIS, and are you ready? How is your database designed? Is it designed to handle big data? Have you built it, indexed it? Are you ready to handle unformatted, unstructured data? And is your data leveraging some of the industry standard data models that are out there? So when you can start to do real-time integration that you might not otherwise be able to do. Is your data application agnostic? Obviously, we still have large number of systems that have very proprietary structures that serve the application. Ideally, you want your data to serve the corporation, the applications to serve the data. So you want a business-centric data store is probably a good sign of a maturity model, and enterprise-wide availability of your business rules so that other applications can do some of the same things and you're not just restricted to editing within your design tool. And using interior architectures, which I'll show in a second. Organizationally, you want to be inclusive. Are you issuing trust dividends to your people? Are you allowing other people to manage and work with your data? Provide them the tools to work with the data rather than holding control in tight. Are people engaged? You want your GIS system to be a corporate resource, you have to engage them. You have to give up a little control to allow other people to have their input, to let them feel they are engaged. Their opinions matter and will actually make changes to what you're doing. And are you integrated to your IT department? Are your GIS analysts pulled together in a closet somewhere, or do you spread them out and embed them within the organization so that they understand what business needs are, and business then begins to learn what GIS is capable of helping them with? I've often seen GIS departments with all sorts of great ideas, but the business doesn't know that they could be getting these kinds of answers through GIS, and vice versa. There's a lot of people with great GIS skills that haven't had the opportunity to really soak up what the business does because they've been in a GIS department and they haven't really learned all the problems that need to be solved, that they can probably quickly offer some ideas on. So this is just a graphic of basically, of that concept visualized is your spatial data store being centric. Your design GIS application isn't your enterprise GIS anymore. It's one component of it that takes care of things. If you want to do an opportunity evaluation, talk to your people, find out what needs to be done. With an interior architecture, you can actually implement solutions for them much more quickly that way. And this is just an example. Here. I saw this last summer in Prince Edward Island on vacation. This is how they still harvest seaweed along the shore. They tried it with machinery, but machinery tears up the the seaweed that they're trying to harvest. So they still use the heavy horses to scrape out the seaweed. So that's it. Thank you very much. I appreciate your time.